Hi everyone, let's go over hexadecimal questions now. You'll see that there's a lot of repetition, and once you get this topic, you probably will only need to just practice it a little. So remember, hex is 0 to 9 and then A to E. It's A to F, sorry. It's worth writing down just that A is 10, and then in fact, if we write down A, B, C, D, E, F, A, 10, 11, 12, 13, 14 and 15, obviously starting from 0 to 15 is where we get those 16 numbers from. So B is obviously 11 and 5 is obviously just 5, but we need to convert them into nibbles. So doing that, we get 1, 0, 1, 1, which is 11. And if you are not sure why, you need to go back and study the binary units. And then 5 would be 0, 1, 0, 1. And then doing the opposite, we take each nibble, so that's 15, which is an F. And then that's a 0, 1, 2, 4 is a 6 for the second nibble. Nice, straightforward, easy 2 marks there. Given two examples where hexadecimal numbers are used, so hopefully we can round these off. So we get HTML color codes and maybe even MAC addresses as well is another one we should have looked at by now in class. Also used in assembly language. And for debugging errors. Now I'll just refer back to this question if it appears again, and you'll see that it does quite often come up. This one is tricky because people don't answer it very well. So we can represent 16 bits in only 4 hex digits or characters. Easy to convert hex to binary and vice versa. Also, just for error checking, is much easier and faster than compared to writing numbers in binary, e.g. 0, 1, 1, 0, which is 6. So if you had this 16-bit number written down and you were trying to check that versus just having something like 66 C, that may not be correct, 4, 8, 12, which is B. Hopefully that's correct. It's much easier to say 66CB versus this 16-bit long byte number. Problem solving question that comes up, we'll just look at the first little piece here. Quite often something like this comes up. So we need to fill in www.cie.org.uk. So if we look up the decimal place, that's 46, but that's its numerical code. That is not what we would just write down here. For example, 99, which is what's in denary, would be written as %sign 63. So we need to take .46, 46 rather, and convert it into its hex equivalent. So if we go 1, 2, 4, 8, 16, 32, 64, 1, 2, 8, and do 46, so we get 0, 0, 1, 32, 14, we would have this value. So that's obviously 2 for that nibble, and then that will be 14 for this side, which we hopefully know is E. So our answer down here, which I'll just change the pen colour so we can see, would be $2E. Then we do the same thing with C, which is 99. So if I just try and squeeze that in on red pen, 99 is 0, 1, and that's 3510, that's 90, 96, and 3 more, 0, 0, 1, 1. That's obviously 3 on this side, and 1, 2, 4, 6, 3. So the C would be percentage sign 6, 3. So basically you're just figuring out what that letter is as denary and then converting it to hex. But people get confused because it's a trickier question. So maybe take the time to practice that one. Obviously we don't have to recalculate the dots anymore because we already did those. So we can just write those in exactly as they are. But that is just a hex question written slightly differently. And you can see there the same idea again, the same question, ever so slightly different, that it's doing the opposite of it's got 0 to E, so you have to figure out what that is. That's obviously 46, so that would be dot. That ends up figuring out as something like rockict.com, I believe. So you can see the dots. Okay, a bit of problem solving, and it's just converting hex to binary and so on. Again, same problem as before, FA7D3E, so F is obviously 1111, A is 10, 1010, 7 is just 7, so that's 0111, D would be 13, so we get 1101, 3, nice and straightforward, and E is 14, which is 1110. Nice and easy. Convert into hexadecimal, take each one. Maybe for these, hopefully you've paused it and just given yourself a chance to do it. So D26, nice and straightforward. More difficult question here coming back from the colours that we've looked at earlier. So we've got the following code shows HTML tag pairs on either side, stating the colour that each creates. So we've got red, green, and blue for these because of the RGB values. Yellow is a combination of red and green, magenta is red and blue, and cyan is green and blue. Describe how other colours, such as a darker shade of blue, are created. So I guess it's just describing how we create these different colours. So a hex code can be 0 to 9 or well, I guess, and A to F. Different combinations are combined to produce different colours, e.g. F, 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 F is white. Don't think that was on the list, yeah. So I guess it's just explaining how that works really, and it's almost answered in the question. You can give a little example for ones. That's often quite a useful thing to do. Give the hex value number of this one. Again, just take each nibble. So we've got 10, so that's A, and 2, which is just 2, nice easy. Showing what's stored in these different registers. So first 3 they represent the row. Each of the 4 characters in the Slayer 4 register, for example, 0 and C. Okay, so this is just straightforward. So we've got 1, 9, 1, 2, 4, and then E. 194E, I believe, is correct for that one. Convert this value to hexadecimal. So you can see we're doing the same questions over and over again here. So 0, 0, 1, 0, 6, 0, 1, 1, 0, 4 is 0, 1, 0, 0, and doing this completely wrong. 0, 0, 0, 0 is what I was going to do for each one. It's actually denary, so it's a bit higher. It's actually a much more complex question, this one. If you can figure this out, you're doing really well. this one's actually beyond the scope of our course, and this is totally wrong. I just assumed it was a hex value we're doing when it's the opposite. So it is straightforward enough to do. If it's a 3-bit hex number, we can use 16 to the power 0, 16 to the power 1, and 16 to the power 2 to give us different values. So this ends up being units, this ends up being 16s, and this ends up being 16 times 16, which is 256s. So if we look at that, we can have 10 256s to give us 2560, which leaves us with 80. 80 is going to divide into 16 by, let's figure that out, 80 divided by 16 is 5 times, and then 0. I'll double check, you can double check my math for me actually, but obviously the answer wouldn't be 10, that would be A50 to get the correct answer on that one. If I'm wrong, let me know, I'll give you some house points. Believe that one's correct. I need to just check my maths. And then writing that as a 12-bit number, A obviously 10 would be 8 and a 2. 5 would be a 4 and a 1, and 0 being this. Double check that one for me. I think I'm right, but I need to shouldn't use a calculator. That one's beyond the course. 40F, nice and straightforward again. I hope you're pausing these and checking them. A is 10, which is an 8 and a 2, and F is top, everything the highest we can do. Nice, I've seen this one appearing a few times. So we've got 105 minutes, 31 minutes, 50 seconds. Write the hexadecimal value of the minutes, which is that one. So we've got 0001, which is obviously 1, and then F for the second part. Nice and straightforward. Questions we've been answering just a few times. Show how this is represented as hex. Well, that nibble there is 1. This is 1, 2, and 8, which is a 10, which is obviously A, and then F, which is the opposite of the question we just did. Show the contents of location 1 and location 2 as hex. You can see they just ask the same questions really all the time. So this is 3, and this is 1, 2, 4. So this one's 43, and this one is 41. Easy peasy. Following machine code instruction is location of main memory, give it in hex, so we split it up into nibbles and just go through. So we'll have F, A, 9, 7. Easy. Explain why a programmer would prefer to see the contents of locations displayed as hexadecimal. So we can think about all the reasons why we're lazy. So it's easier to read than binary. Now this is key for exam skills. Most people just write this part and forget the part that actually explains what's going on. Easy to read in binary. Read, and what we can say is the same there is understand. I believe we already answered this one. It's easier then to identify and fix errors, and less screen space is used to display information, e.g. a 16-bit number could be conveyed with just 4 hex digits. So if that was the screen on an aircon unit or something, you could have a lot of different error codes appearing. Again, convert this instruction, we'll just do the answer here. So it's 2, that's 8 and 9, F 1, 2, 4, 8, 12, 10, 11, C. So again, I just take my time to make sure I get those correct. Explain why a programmer might prefer to read the instruction in hexadecimal rather than binary. Same as all the reasons we just wrote a few questions ago. Have a look at that one. Two other uses of hexadecimal. We looked at that one. MAC addresses, data instructions, hexadecimal. So that's obviously instructions. So the other one then could be HTML color codes. I guess we already answered one too, so we'll skip it next time. Contents of the register represent a binary integer. There we go. Convert the binary integer to hexadecimal. 3, 1, 2, 4, and 8 is 10, 3A. Double check you're getting those correct. Contents of this register can be binary. What are they in binary? So we got 1, 2, 4, 8, 16, 32. So a bit of maths. 48, 52, 55. And then in hex, we're going to have 3, 7. Hopefully that's correct. Let me know if it's not. Okay, we already did this one of what are some of the other uses. I guess the one that we didn't say earlier is maybe memory locations. And again, it makes it much easier for the programmer. Another one that we could say is part of MAC address is IP addresses. Can be represented that way. Error messages or error codes in memory, which is kind of, well, it's not too similar as the first one. There we go. We'll skip that one. Explain why hexadecimal is used to represent binary numbers. Because we're lazy, it's easier for us to read and fix errors. We are lazy. We like to make things much easier for us. Converting to binary is much easier for a hex number, and then if you think about display on screens, it's much more condensed, so you can have smaller screens to display information, therefore making things E04, EF, so that's obviously 1, 1, 1, 0, 0 is obviously 0, 0, 0, and then 4, 0, 1, 0, 0. Take your time with those, double you got it correct. State why hexadecimal, smaller screen. Okay. Reading that question, it's all about why you use hexadecimal to display the error code. Smaller screen, and that means less memory to store all the error codes, to store the messages, because you could just put out E04 instead of saying text to store this piece of text here, for example. Would take a lot more memory to store that sentence versus just storing E04 as the code. Much simpler way of doing it. Good problem solving one here again. Right carried out by a robotic arm, so we've got 9, so we need to figure out that as hex, so it's 1, 0, 0, 1. Looking at that, if we then find that, it's left. And then we just do the same for the other ones. 1 should be easy, there we go, it's down. C is obviously, A, B, C is obviously 11, so we get 8 and 3, so 1, 0, 1, 1. 1, 0, oh, 10, 11, 12, oh, just as well I double check my answer there, 12, so it's actually 1, 1, 0, 0, and 1, 0, 0, so looking that up is open. So you see how easy it is to make mistakes if you just try and do things too fast. 0, 0, 1, 1 for 3, which is close, and then F is 1, 1, 1, 1, which is up. So again, I fall into the same mistakes all the time, that I try and do things too quickly. Slightly trickier question here. So we've got 3 hexadecimal numbers. We've got 2A, which is obviously 0, 0, 1, 0, followed by 10, which is 1, 0, 1, 0, which we then convert to hex. So we've got 2, 4, and 8, and a 32. So adding those up together is going to give us a total of 42. Let's change the pen colour for the next one because that's slightly longer. So we've got 101, which is 0, 0, 0, 1, 0, 0, 0, 0, and then 0, 0, 0, 1. Adding those up, we've got a 1, 2, 4, 8, 16, 32, 64, 1, 2, 8, 2, 5, 6. So that's hopefully straightforward maths to give us 2, 5, 7. And if we apply the same logic, let's just be lazy and use another pen here. 21E, so 0, 0, 1, 0, 1, 0, 0, 0, 1, and then E, which is 14, because F's 15, so we get 8 and 4 is 12, 2 is 14. Adding that up, and again I'll just change my pen colour. I've got 1, 2, 4, and 8 is 16, 32, 64, 1, 2, 8, 2, 5, 6, 512, and then adding up all of those, 5, 12, 16, 8, 4, 2 gives us 542. Hopefully the math's correct here. Again, for practice, double check those with a calculator. That's a very tricky question actually, so make sure you can do these ones. So we get, again, hexadecimal, 12-bit digits. They're trying to put some text in here to confuse you. It's the same thing that you always do. So D, we should know as 13. Let's just double check. A, B, C, D. So 10, 11, 12, 13. So you want 13, 1, 1, 0, 1, 0, easy one, and then 3, 0, 0, 1, 1. Same question we've had a few times, so hopefully you just take a minute to do that. Convert the identity number 179 to hexadecimal, so we need to get our 1, 2, 4, 8, 16, 32, 64, 1, 2, 8 grid written out. So 179 away 128, which leaves us with 51 remaining, so 0, 32, and 16 is 48, and then 3. So we end up with 3 for the first nibble, and then we are 1, 2, 3, and 8 is 11, which is B3. Double check for me. Let's see. So we have IP addresses representing these ones. So basically the same question. What is the correct hex of each of them? So that's 1, 0 for this one. We've got the second nibble there is going to be FE, because that's obviously 15 and 14. And the last one is 0, 9. Straightforward, take your time, double check, do them again with me there. Explain why they use this. So again, it's errors and understanding. Same one we've got before. Have a look back if you're still not sure of that one. Less likely to make errors, easy to read and understand. Explain why they use that one. Easier to read and understand, and you can represent the information with less characters. Convert 3 digits into hexadecimal. As you can see, just draw the split the nibble. So 1, 2, 4. And then the second one is 3 plus 8, 11 for B. And then we have 4 for the second one there, with 1, 2, and 4, which is 45 or 4, 5. And then that's obviously 5 on that last one again, and then 9 forward, hopefully. 3 other uses of hexadecimal in computer science. We already did this one. Have a look back. IP addresses, MAC addresses, error messages, locations in memory, assembly language. State 2 benefits of using them. Again, there we go. You can make less errors, easier to debug, error check, spot errors, easier to read, write, understand. Have a look back for the correct answers. Again, practice these ones. 97, 1, 0, 0, 1, 7 will be 0, 1, 1, 1, 5C, 0, 1, 0, 1, and C is 8 plus 4, 12, 1, 1, 0, 0, and then E is obviously 14, 1, 1, 1, 0, and 1, Nice and straightforward. There we go. Give two other examples of where you can use it. You see the same ones appearing again and again and again and again and again. Go back and look for it at the previous ones, add it to your notes. It's the classic ones that people make mistakes on. There we go. Same questions again. There's two. Nice and straightforward. 3, 0, 0, 1, 1. F 1, 1, 1, 1. 5, 0, 1, 0, 1. E 14. Easy. And D 1 less is 13, so 1, 1, 0, 1. Easy 6-mark question. If that comes up in your exam, you'll be pleased. Explain why the designer used hexadecimal notation to represent binary values. Same question again. Debugging, spotting errors, fixing errors, less likely to make mistakes. Explain is the issue there if people will just not know it well enough. State the hexadecimal equivalent of this one. Now I just defaulted there and you can see that it's not as simple as I thought it was going to be. You can see that it's not laid out the same, so let me just highlight the first four. So there's nibble 1, there's nibble 2, and then we've got nibble 3 of these last two characters. That's really good drawing. There we go. So again, key takeaways for me is I need to slow down a little. So hex equivalent of those. For that first one, we've got 1, 2, 4, which is 5. The second one is 1 and 2 is 3 and 8, which is 11, which is B. And then we've got 0, 1, which is actually a 2. So we've got 2, B, 5 for our characters there. And again, you can just see the types of questions that come up. F 1, 1, 1, 1, 9, 1, 0, 0, 1, 2, 0, 0, 1, 0. A is 10, 8, and a 2. 1, 0, 0, 0, 1, and then 0, 0, 0, 0. Again, straightforward enough, just practicing the same things. 3 stored in that register, 0, 0, 1, 1. A is 10, so we've got 1, 0, 1, 0, and then 9 is 8 and a 1. There we go. Try and write it a bit neater than I have. Last question, same one as before, the same things that always appear. MAC addresses used in assembly language, error messages, memory dumps for error codes, HTML color codes, the ones that we looked at previously. Add it to your notes. That is everything about hexadecimal. Nice and straightforward. I hope you agree.